Advanced analytics and artificial intelligence can be used to help manage challenging issues related to mitigating climate change and improving adaptation and resilience. The changing climate will have a major impact on environmental, social, and economic systems around the globe. Mitigation is therefore critical, including efforts to achieve net zero emissions by 2050. However, minimizing the harm will also require increasing our efforts at adaptation and resilience. AI as a tool is uniquely positioned to help manage these complex issues. Due to its capacity to gather, complete, and interpret large, complex datasets on emissions, climate impact, and more. It can be used to support all stakeholders in taking a more informed and data-driven approach to combating carbon emissions and building a greener society. The AI opportunity. Global public and private sector leaders surveyed see the greatest business value for AI in the reduction and measurement of emissions. However, there are many diverse ways in which global leaders can use AI to achieve their goals. First is mitigation. AI can be employed to help measure emissions at both the macro and micro levels, reduce emissions and greenhouse gas effects, and remove existing emissions from the atmosphere. In a survey, for example, AI can be used to help reduce GHG emissions equal to 5% to 10% of an organization's carbon footprint, or a total 3 to 5 gigatons of Colorado 2E if scaled globally. Second is adaptation and resilience. AI can be applied to improve hazard forecasting for regionalized long-term events, such as sea level rise, and for immediate, extreme events, such as hurricanes, among other possibilities. These applications include the management of vulnerability and exposure, such as by developing infrastructure that can minimize the impact of climate hazards. Third is fundamentals. AI can also be used to bolster efforts across climate research and modeling, climate finance, and education, nudging, and behavior change, such as estimate an individual's carbon footprint. AI can be employed in 5 leading ways: to gather and complete complex datasets, to strengthen planning and decision-making, to optimize processes, to support collaborative ecosystems, to encourage climate-positive behaviors. It can therefore serve as a tool for helping stakeholders, from businesses and governments to NGOs and investors, take a more informed and data-driven approach. Note that AI is not the solution itself, but a tool to help leaders and citizens make informed judgments about how to tackle climate challenges. Obstacles to progress. While there are some areas where AI solutions are well established and ready for broad application, such as emissions measurement and the monitoring of natural carbon sinks, existing AI-related climate change solutions today are more typically scattered, difficult to access, and lacking the resources to scale. In addition, not all organizations are yet actively engaged in climate and AI topics, while even leaders already engaged in this space face many obstacles to climate AI use. Need for meaningful support. If they are to achieve wide-scale adoption, AI solutions need to be designed for user-friendliness, regardless of whether they are developed for corporations, governments, or the general public. They need to be easily accessible, offer tangible benefits to the user, and provide clear information to guide user action. Resources and networks. Promising solutions also need resources and networks if they are to maximize the potential of AI in addressing climate change, particularly in the Global South. They need access to capital investments, decision-makers, and trained practitioners, allowing them to be deployed at scale. Financial support can bridge the gap between academic research and at-scale deployment, while connections to policymakers and corporate leaders can help boost awareness and adoption. In addition, sharing knowledge on best practices and promising applications can ensure that solutions are ready for widespread government and corporate deployment. Capacity building. Training and reskilling can ensure that civil servants, private sector leaders, and other stakeholders use and interpret AI solutions effectively in the most critical contexts. Today's AI research, predominantly run out of institutes and corporations in the global north, needs to become more inclusive, as it risks neglecting the needs of the global south. Confidence and trust. Given its complexity and the risks of unethical behavior, whether intentional or unintentional, users of AI need to earn the confidence of climate leaders. Solutions must therefore use AI responsibly, employ granular and reliable underlying datasets, and emphasize results that can be interpreted and understood. Despite its promise, we note that AI cannot be used to solve the climate crisis in isolation. Rather, it is one of many tools that should be employed to address this global challenge. Individuals, communities, and organizations who have a part to play in combating the climate crisis should consider how other emerging technologies can help and assist in removing obstacles to scale for those as well.